Hello everyone, my name is Tomasz Szewczyk, PCSS, working in work package 6 task 2, and today I'd like to show you brief information about deployment of Maat in PIONIER network. First of all, briefly how the agenda looks like. We start with quick update of PIONIER network and our justification why we decided to go in automation orchestration systems. Then I will show you what is the role of Maat in PIONIER orchestration system. Then briefly I will tell you how we modeling services and resources and how this infrastructure is used in our production network. And then briefly I will explain you why we chosen that approach and why I think it is successful in our environment. So first of all, as some of you may know, PIONIER network consists of 21 main POPs, which are connecting metropolitan area networks built in academic centers in Poland. 5 of them are also high-power computing centers. In PIONIER, we're using our own optical transmission system, which uses own fibers. And recently, we deployed a new MPLS packet network, which consists of very different devices. Even if they come from single vendor, they are working with different operating systems and using different hardware platforms. So this is why we decided to automate the configuration and orchestration of services we're providing in our network, because we would like to keep consistency and error-free in deploying in this very differentiated environment. So how it looks like in how our orchestration system looks like. First of all, we model our resources and services in Maat, which allow us to describe resources and services, and secondly, it avoids data duplication, because in many approaches we know people are using different systems and sometimes synchronizing data between different systems, which creates potential problems, can create potential problems. We use also workflows in order to collect input from users. So basically, if user want to request service, it has to fill some basic data needed to provision that service. Then workflows interact with Maat API, which is bidirectional, because the workflow can request some data from Maat, or can create some object or modify existing objects in Maat database. And at the same time, the workflows control implementation of configuration on real devices. And also we have functionality related to changelogs, so we are able to continuously monitor the changes in our single source of truth database, which in our case is Maat. We also securing access to given elements of that system using Keycloak, which is natively integrated in Maat application. So there is no additional, I would say, software needed. There is native integration between Maat and Keycloak. For automation, we're using Apache Airflow. And for applying configuration to devices, we're using GÉANT LSO system. So what was our motivation to start with Maat was that we would like to be very flexible in modeling our resources and services. Maat uses TMF standards in order to do that. So what we've done, basing on TMF specification, we divided description of objects in database to resources, which represent all we have in our network, and services, so all instances which are deployed in network in order to provide services to end users. So as you see on the slide, thanks to properties of TMF standards, we are able to describe different types of devices and model those devices in the way that they are constructed in real world. So basically, if we have a router or switch has interfaces, can have some modules. The router comes from given vendor and its particular model of the device. So everything, as you see, is represented as objects in Maat database. And second key feature of TMF specification and Maat application is that it supports relations, dynamic relations between objects in database. So as you can see here, we can create different relations which models how our resources are represented in database. The same is for services. Here you can see on the right side, you can see a general model of service, which consists of object representing and describing parameters of particular service instance. And this object is connected with service access point object, which represent the service termination point or the point in network where the end user receives the service. We have also some extra objects which are used for very specific purposes. So how looks the orchestration in our infrastructure? Right now, we defined in production Maat database about 1400 objects related to resources, and they represent our routers. So for the moment, we have all those main routers from 21 POPs plus some regional nodes. All interfaces we have on these devices are also included in Maat database. We also created some objects related to customers, but it means they are not necessarily customer which purchasing service from us, but they are representing entities we provide service for. So basically, if there is in our case, there is a service which we light to circuit service which delivers traffic from GÉANT to router, then we define GÉANT as customer because in case of any failures or problems, we'd like to know that we should notify GÉANT that there is a problem with some service. And in Maat database, we also defined about 1300 objects related to services. Mainly right now, they are point-to-point layer 2 circuit service called E-line. And we started deploying the orchestration system with that service because it's most popular service in Pionier network. We have much smaller number of VRFs and EVPNs. However, for some early experiments, we also implemented in Maat our configuration of our core network, which, for instance, was used to present in fancy way the network topology. So that's something we're using right now. And workflows was from the beginning from the starting of implementation was running more than 300 times, which means we deployed in the network more than 300 services. So in our case, that are layer 2 circuits. This is because we did not started orchestration from day zero. So network was running with services, and what we have to do was to move existing services to Maat database, and then new services were implemented with workflows and Maat application. So in order to accelerate the development of automation and orchestration processes, our colleagues and we are using user interface, graphical user interface, which allow us to see what is inside the Maat, because by design, Maat stores data in JSON format. And for readability and for convenience of engineers, we created user interface which allow us to see what's in the database for quick browsing, for some manual editing, for instance, because as I mentioned we did not started from day zero of our network with automation. There was running network from which we have to extract some information and put this information into Maat database. And this process was somehow automated. So for the data we were able to extract automatically from devices. It was done by scripts. However, some data were introduced to Maat manually. So right now we have we're trying to put to the Maat as many information as we can, even if we don't have workflows defined for particular elements of configuration. So the UI is very nice from the user point of view, because it reflects how the structure of Maat database and TMF specification. Because each object in Maat database has a type field which reflects its property related to it is service or resource. So we have two tabs related to resources and services, and we have dynamically created a category pane which defines objects we as PIONIER are defining in the database. So as you can see on the left pane, we have vendor, model, customer, site, device router, interface, and group and identifier categories of objects. And when you click on the given category, you get a list of objects defined in Maat database. Additionally, the UI supports text searching, filtering, and property selection of properties you would like to display in this tabular output. And at the same time, you can also look at raw JSON object to see how the object is stored in database.
Tomek, 3 minutes left, okay? Tomek?
Okay, yes, I'm going to speed up.
Mm-hmm.
Yeah. And at the same time, we can manually correct or introduce some new attributes for given objects. And UI also supports links to references. So basically, if we have references between two objects, you can quickly move to the object which is referred by given link. So what is the nice stuff about Maat is that it allows us to define new objects, new services, even if we don't have yet the workflows implemented. So for the moment, what we're doing right now, we finished almost working on EVPN definitions in Maat. We also have VRF instances. Right now in deployment instance, we have defined parameters for protocols and in BGP in particular, and routing policies which are used by protocol BGP. So in near future, we can easily start to fill our production Maat database with all that information. And for user convenience, we also prepared integration between Mattermost and Maat database in order to allow for our NOC operators and our Metropolitan Area Networks administrator to get access to particular elements in the Maat database, so they can basically get information what is the parameter of particular service instance, what services are implemented on particular interface on the device, or what are services connected with particular customer or user. So thank you very much, and if you have any questions, just let me know.
I think Tomasz gave a very nice introduction to what we're going to discuss next, and this is the AI support for network workflow design and implementation. Namely, what we were doing as part of the GP4L team is what Tomasz discussed before, the whole service design, the design of the workflows, the API integration with the rest of the components, where the single source of truth Maat that Tomasz was discussing about is one of the main components for these workflows. And it took us a number of people and a lot of time to develop the first design, the first workflows, and then make this integration happen and be implemented in production in PIONIER. So it really requires a lot of effort, and it requires time and knowledge. And this is kind of a problem for smaller NRENs that do not have this manpower to be supported when they want to implement orchestration and automation for network services. So at some point while discussing, we asked the question, can we somehow use AI to support us in this process, to help us with the design, to help us with the implementation of service data models and workflows? And we said, okay, let's try and test it out and see how much can it actually help you. And what we did was we actually tried to replicate the case of the creation of the first workflow for the first service for PIONIER, which was the line point-to-point circuit, but in a virtual environment. So we used the GP4L infrastructure in Container Lab. We created a virtual network. And then we replicated the whole environment using Ansible, Jinja, LSO, Airflow for the workflows, Maat as the single source of truth, Git as the place where the workflow definitions are going to be stored. What we changed in this case is that we don't have the human anymore to develop the workflows, but we use an AI assistant. And we tried different assistants. We tried the Microsoft Copilot. We tried the Gemini from Google. We tried ChatGPT. And in the first test, it turned out that ChatGPT is providing the best results, making a minimum number of errors. So we said, okay, let's try and use ChatGPT. At the moment, it was version 4.0, and see how much we can design and develop. Can we get to a point where we are going to have the workflow is implemented as good or even better than what we designed and implemented in PIONIER? So this approach is basically what is now popularly called vibe coding approach. That means that we have an interactive, iterative conversation with the AI. We don't develop any of the code. So zero of the code is manually produced. Everything is provided as code from the AI based on the natural language input that we provide to the AI. The requirements that we gave to the AI from the start, and are very, very strong requirements, are very important requirements to get good results, is that the AI has to produce code and design of services that is TM Forum compliant, including compliant with the Open Digital Architecture, and use the TM Forum APIs, as Maat is exposing these types of APIs. And at the same time, we told him that everything you produce as code, it has to be reusable, it has to be modular, it has to be adaptable. So we started from this point. Basically, what we did all the time, we went through an interactive loop where we give a prompt to ChatGPT, to the AI assistant. He is going to draft a code for the workflow based on the prompt. We copy-paste that code, we test it in the virtual environment, we provide him back with the errors that we get. If we get errors, he tries to fix the errors with new code. We use that code and we tell him, is it okay or is it not okay? Additionally, we might ask him to add additional features or do another part of the code during this process. The whole thing can be actually divided into two phases. The first phase, very important phase, is the phase at the beginning where you start the conversation with the AI assistant. The first thing that you want him to do is to design the service and to design a workflow blueprint that is going to be used as a scaffolding for the rest of the code that will be developed inside of all of the modules and functions that are going to be defined. This is what is called holistic prompting. So the first phase was holistic prompting. In this case, we were using very long, very detailed prompts. So for an example is provided here, where you see you have a long prompt that tells him all of the components that are going to be in play, what types of components are these, how I want to talk to them. It has to be compliant with TMF and everything. So we used a number of these long inputs in the beginning to get the design and the blueprint. Once we were happy with this phase, then we went into the second phase where we used granular prompting. So we had shorter prompting, telling him to improve something or to fix something because we have an error. In case of an error, we were just copy pasting the error. In case we want to improve something, we use a short prompt, as the example is here, add automatic retries on any HTTP call. It was a very fun, very interesting test. We got very interesting results. For an example, it turns out that the AI assistant is very, very extremely good at service design and blueprinting of the workflows. He is very good. Why? Because he actually understands the TM Forum Open Digital Architecture and the APIs completely based on all of the documentation that is provided from TM Forum. You don't need to provide the documentation. It seems that ChatGPT has already went through all of the documents and digested everything. So just by giving him a prompt that says, please design a layer 2 circuit that is going to be TMF compliant, you already get an output that is correctly TMF compliant, has all of the main features of the layer 2 circuit. And when you tell him, I want it to be scalable, reusable, modular, and everything, he does it really in a way that it can be implemented in a high-scale environment. It can be reused by nRuns and everything. What he lacks and what he needs at the stage of service design is guidance on component-specific logic. So if you want parameters in the service that are very closely related to the type of resources that you have in your environment, you need to describe this to him and tell him so that he will do it for you. Otherwise, he's not going to include these types of parameters. The same thing happened with the blueprint for the workflows. So we told him, okay, we want the workflows for this service. We are going to use Airflow. It's very important to tell him which version of Airflow, because there are differences between the versions, and he takes this into account. He does a very good, very modular design. He explains to you why he is doing this so that you understand. So the effects are really great, and you can practically use them out of the box. So there were just a couple of maybe errors here and there that were very easily fixable with the prompts, and you actually are able to get a very good service design and very good blueprint for your workflows from the AI assistant using Vibe coding. During the whole process, he is guiding you. So he is telling you this, and you can ask him questions and he is going to answer. Why did you do it like this? Because of this, and what happens if we do it differently? He is going to compare the approaches and he will tell you, I recommend this because it's more scalable or more reusable or something. But if you insist and give him a command saying, I want it like this, he is going to adjust it based on your input. So you have to be careful when you're choosing and making decisions when he allows you to do decisions. In the second phase, when we started filling out the code of the blueprint, this is where he got a bit more difficult to work with. He was making more mistakes. Almost nothing was working from the first running of the code, but he was quite good at the iterative prompting. So every time I would copy paste an error, he is going to give me new code, which is actually fixing the error. So he finds his way around the problems. However, it takes you more time, and it also needs you to understand what is happening so that you are able to sometimes explain to him the error a bit better. One thing that was very important is that at some places, for an example, interaction with Maat. Maat is not a standard application or tool that he already knows about. It is something that is new to him. So you need to explain it very well. In this case, the best explanation was actually to provide him with the JSON schema for the data model and the API schema for Maat. Once we gave him this information, he was ready to produce correct code every time any type of interaction is needed with Maat. Without it, it was impossible for him to produce any code that is going to talk to Maat correctly as he should. Basically, the main takeaway is that the more detailed information you provide, the more usable is the output. If you don't provide him information, he has to invent the information. And in this case, most probably he is going to make an error because he is going to invent something that is wrong. Most of the problems where they were happening were actually in places where we figured out that we haven't given him enough information. So basically, all of the hallucinations are happening when he needs to fill up some holes because you didn't provide them in your detailed explanation. From time to time, during the conversation, it might happen that you ask something to understand or whatever, and it takes him in a very strange direction, and then he starts to produce gibberish. And this is what I call falling into the rabbit hole. I cannot really tell you when and how is this happening. It's just sometimes when you ask a question like, by the way, or something, and then he moves into a different direction. Our takeaway is that once he does this, there is no coming back. So you cannot make him forget something from before. Even if he tells you, okay, I'm not going to use it anymore, it will keep coming back here and there. You cannot do it without him. So better to start over in a new conversation from scratch, other than trying to fix things with him because it's not working. Anyway, the good outweighs the bad. So in the end, you really get an ultra-fast design. I mean, several times faster than we did it manually. Very, very, very good for prototyping. And he is going to put everything inside. So he is going to think about security, about availability, about scalability from the beginning, from the design, not as an afterthought as we usually do it when we do it only purely human. For someone who hasn't used and coded in Airflow before, he's a great teacher and he will guide you through the whole process. So in this way, you really can lower your learning curve, and it will take you now hours instead of days to actually do something. So we believe that there is really a potential on using an AI assistant to help you developing standards called compliant or orchestration at scale. What we want to do next is we would like to try to use AI agents to develop dynamic workflows, because this use case was using an AI assistant to develop a static workflow for a given service. Now, because he was so good at doing that, and we are very happy with his performance, we would like to see how good he is going to be at actually creating and designing the workflow on the spot based on the behavior of the network. Of course, we want to also test multi-service, multi-domain workflows and see if we can actually teach AI to behave differently based on our corrections, which was one of the main problems that we had before. This is everything in a nutshell. If you would like more information, please come back to the GP4L website, where we will put all of the details of this story shortly in a week or two. Thank you.
My name is Marcin Adamski, and together with Piotr, we created a presentation about workflow security with Apache Airflow 3. My presentation will be probably much shorter than previous. So I have only three main slides. On first, I will present architecture from security perspective, how it was done, and after it, I will talk a little bit about authentication and authorization. So about system, the system consists of four main services. We have here Airflow, which is a very advanced orchestration tool, in which we have defined several workflow, which named an Airflow DAGs, which are responsible for creating circuits, creating some for configuring network items, etc. It is possible to create L2 circuit, to delete L2 circuit, EVPN, and a different one. Yeah, we have also Maat, in which we store all networks components definitions, and LSO, which is used to perform action on infrastructure. We have UI form which are connected to Maat to gather information from Maat and use it for Airflow to run workflows based on this information. Of course, we use Keycloak for from security perspective, which is integrated with Maat, Airflow, and UI components, and provides security fraud authentication authorization mechanisms. About authentication, in Keycloak we have defined some security context which name is realm, in which we have 3 clients for our components. We have a client for Maat internally, for Airflow, and also for Maat UI forms. And comparing to old solution in which we use basic authentication headers and system, it is much better now situation because user provide information like username, password, and only in Keycloak web application, and based on this information, Keycloak returns access and refresh token to UI form, and based on this token, this UI form can connect with API from a specific service. We found one main difference between the process of working with the services, because it is possible to use access token to access, for example, Maat, but it is not impossible to use this access token from Keycloak directly to use for access Airflow, because Airflow has some additional layer of security. He use JWT tokens in which we have access and refresh token, and it makes from security perspective maybe something more, but from accessing services a little bit trouble to access to use services, because every time if we would like to access for example Airflow, we have to connect to Keycloak to get access and refresh tokens, and after it we can use it to access API. What is also here important, this approach which I described now with this JWT token is now under discussion on Airflow community, because there are 2 different perspectives. With security that is maybe a little bit better, but from using it, it is under discussion. And the last slide which I have is connected to authorization, and we use authorization policy which we have in Keycloak. We have defined some roles in context of our realm, for example, like Airflow admin, and we use airbag model for accessing this for storing this policy. Airbag is role-based access control model, in which we define from one side roles and from different one resource and actions which could be performed by someone. We use pull model, in which it means that every time our services Airflow is asking Keycloak for specific operation, if someone is permitted or not to do it. It is also able to use some push model, in which we got full security policy at first time, and during whole session the security is valid, and if someone changed something in security policy, it will be visible under next after some period after we got a different session. So in our policy we have also, so in our airbag we have from one side policy which consists information about roles which will be used for specific permission, and from the different side we have resources for which we define action scopes which could be done for these resources, and all together are connected by permission. So example permission is visible on the down on my slide. So Airflow admin role can perform put, patch, post, get scopes operation on all DAGs. It's very important is also that it is possible to create some specific policy for specific DAG, because DAG could be described by some attributes. So it is possible to create a policy for specific single DAG also. So it is last my slide. Thank you very much.
Hello, my name is Marcin Siuda. I am from PCSS, and today I would like to present the REST API in Maat. Maat, our source of truth component application that we developed in the GÉANT project. During this presentation, I will go through several aspects of Maat REST API and its importance in communication and information exchange. We'll look at how the API is structured and used in practice. I will tell you about the advanced filtering in API, also about the authentication and authorization mechanism in Maat, event notifications, and additional tools like Maat text. The main goal is to show that the REST API is a key element in communication between Maat and other systems. Maat is a source of true application, is the central point for storing and sharing information about resources and services in our infrastructure. It's very simple Java application integrated with the MongoDB database and implemented a REST API interface. And the REST API is the main integration interface between Maat and external applications. It enables fetching, adding, modifying, and deleting data about resources and services. And however, we can combine Maat with automation and orchestration tools, of course, and it becomes an important component in infrastructure management system. And we also are really proud to announce that Maat has been operating in the production in the PIONIER network for a year last year. Yes, so advanced data filtering. One of the strongest features of Maat's REST API is advanced data filtering. Thanks to the set of query parameters, user can precisely select and find the data that they need. For example, we can search only resources with the specific name, category, types, nested relationships. Also, it's possible to show only a few fields in response. Only, for example, only the name and category, and limit the data, use regular expressions, or sorting the data in response. Advanced filtering, of course, is working for both resource and service part by sending the request on a specific URL, like on the left for resources and on the right for service part. So authentication and authorization in Maat. Security is, of course, really important for us, and in Maat, we pay a particular attention to this aspect. Regarding authentication, we have implemented restricted access to the REST API, so only authenticated user can and client applications can interact with Maat. Also implemented the user authentication for access to the Maat graphical user interface. And regarding authorization, we also introduced two levels of authorization. The first level defines access to the REST API methods. There we can determine who can read, create, update, or delete and data, and we can combine this reading, creation, update, deletions. So yeah, the second level restrict access to a specific resources and services. So we can determine that a user have access only for the specific resources, for example, for routers, only switches, etc. For both authentication and authorization, Maat uses, of course, Keycloak that we mentioned before. The Keycloak as an identity and access management platform. And event notification system. In Maat, we have the possibility to send notifications to external applications which can register in Maat as listeners. This mechanism allows to store a history as the history of changes that occurred in Maat, such as resource creations, updates, service deletions, etc. And any example is the event listener application, which receives and store all notifications from Maat. And through its own API, we can query it by tools like a Postman to view the event history in the JSON viewer, or we can visualize this in, for example, in Grafana by the Grafana Loki as a table view or charts. And MaatDex, another tool that we have integrated with Maat, it's used to fetch the network topology data from Maat and also from external sources, such as monitoring systems for the measurement data. The exported data from MaatDex is used to visualize network topology, for example, in Grafana, and we're using plugins like MapGL or Network Map Panel, and the results are on screen. And all process is described in the use case section in the official Maat documentation website. There is the link below. Okay, and the last future work. We currently working on integration Maat with AI and LLM models. For example, through the MCP server, use the REST API, of course, using REST API. The goal is to allow users to make complex queries using a natural language. So we can say, show me all services dependent on router in Warsaw, for example. This work is still in research and testing phase, but initial results are very promising, and probably we can tell you more in the future about this. For more information about the Maat, you can found this on the official document page. There is the link and the QR code. We also recently released several video tutorials available on the GÉANT YouTube channel, showing how to use the Maat from installation to integration with Keycloak, so you can find more information there. Thank you very much.
Thank you very much. Hope you see the slide already. So I will start off providing some introduction as usually to NMaaS and the currently supported use cases. I will briefly describe the newly added features that might be interested for current and potential users. Mention a few applications that were recently added to the portfolio, and then Vojdan will take over and dive deeper into the new use case that we are currently working on, and also will describe some plans how we would like to move forward with NMaaS evolution. So basically, what following the major rebranding we already started last year, we would like from now on all the users and the whole community treat NMaaS as a versatile open source orchestration platform that is no longer bounded to a single use case, and the, let's say, network management as it originated from. So now NMaaS is capable of supporting various use cases. Supporting meaning that NMaaS provides the necessary software features if required, but also new use cases can solely rely on the applications that are basically available from the NMaaS catalog. So out of them, users can build some systems, more complex applications that can be put into practice to solve various issues that the users may be facing. So currently supported use cases are virtual NOC, that is of course an evolution of the initial network management as a service solution, and the other one is virtual lab that is already with us for quite some time. And for those two use cases, we already have two dedicated NMaaS instances deployed and available for users to use. Virtual NOC is our production service instance available at vnoc nmaas.eu, and VLab is also more testing platform for virtual lab organization of virtual laboratories, available under VLab dev nmaas.eu. Recently, we were able to finally finish our production users migration to the new infrastructure, IT infrastructure provided by PCSS. So from now on, we have a new landing page under nmaas.eu, which you can see here on the bottom left, and it contains a redirection to the new vnoc instance that up till now was also available under this domain. And this landing page contains various pointers and references to our documentation website, but also to the instances, NMaaS instances that support particular use cases, and also dedicated documentation pages for each of the use cases, which you can see on the right. And this is how we would like to approach this from now on. So our main focus is now on developing new use cases and presenting those to the community to hopefully attract new interest and from new users. And each use case will have its own dedicated information page to clearly identify the benefits and in the scope of given how NMaaS can be applied in various scenarios. Also, recently we have released version 1.8.0 of NMaaS that contained a lot of new features. What I will show also in dedicated slides is that we have now delivered a new, completely redesigned web interface of the portal. We have also introduced some initial support for webhooks. So currently, administrators can set up notifications that are being sent out to external systems, added to NMaaS, based on 4 supported actions that take place in NMaaS. For example, that a given user is assigned a new role, or new domain is being created. So this can be an input to some automation workflows that take place and are, let's say, delivered by dedicated third-party systems outside of the NMaaS platform itself. We have also introduced the option for application pausing and resuming. So this is mostly to be able to preserve resources of the underlying Kubernetes clusters, especially important in the virtual lab context. But also this allows now to use this option for some time sharing and some multi-tenant access to some resources. And I think Vojdan will touch on this later on as well. We have also simplified a little bit the NMaaS architecture, removed one of the software components, which was the janitor that was doing some low-level interactions with GitLab and the Kubernetes API. So this functionality was moved to the platform itself. And also we did some other adjustments in order to make the platform easier to maintain. And also some other technical improvements like the improved application health checks. So that was also very much needed. So this is how the UI was redesigned. We see the old design on the left and the new one on the right. We have also, using this opportunity, we have also introduced the dark mode that might be interesting for at least some of the users. So we have moved the top navigation bar to the left. So this is especially visible for users with some administrator roles. So all the options are now visible on the left. And we have also introduced the new dashboards that differ depending on the role that a given user has. That clearly showcases some statistics from the platform that might be particularly interesting for a user with given role. Regarding some applications that were recently introduced, this is just a very brief overview. And what we wanted to mention is, for example, Checkle. It's a brand new uptime monitoring application which was introduced beside Uptime Kuma that was already supported. We have also integrated some very nice pgback web application that can be used for automated PostgreSQL database backups. And actually, this is used also in PCSS to backup for scheduled backups of databases from various services that we are offering to our users. So the application provides a very nice UI where you can schedule the backups and you can also trigger restore of the databases. So that's very nice. We have a metabase application that Vojdan will mention in a second as well. So we have recently also added N8N application apart from the Apache Airflow as the workflow orchestrator. And apart from this introduction of new domains, we are also making a constant effort to upgrade applications that already exist in the portfolio to their more recent versions, like for example this as an example introduction of Prometheus version 3. Okay, let me give the floor to.
Now we'll pivot to the support for the new use case called remote K8s clusters. And basically, the gist of this use case is that so far, since its inception, NMaaS has always supported only a single Kubernetes cluster. So NMaaS was able to deploy applications only on the cluster where itself is running. With this new use case, we aim to add support for also managing of remote Kubernetes clusters. And this means that the same NMaaS application catalog can be used for deploying applications also on remote clusters. The first feature implementations supporting this use case and this work are already available in version 1.8.0 of NMaaS that Lukasz has just mentioned. And the main benefits of this new approach are that the applications can now run fully on premise. So they're no longer offloaded to a cloud-based infrastructure or the central NMaaS instance. And by effect, this also means that there's no longer a need for complex site-to-site VPN connectivity between the application acquiring the data and the data source, because in this case, both the application acting as a data source and the application acquiring the data deployed by NMaaS would be running in the same network and can use the existing network. This provides full control over the data without any privacy concerns or concerns over unauthorized data access. And when it comes to access to the web interfaces of the applications, or what is known as the client access to the applications, previously NMaaS required the use of a client access VPN. In this case, by running the applications locally within the same infrastructure, interested users can directly access these applications from their own workstations on premise, or can use simply existing client access VPN technology to connect remotely. So something that's already used within the company or the enterprise. We must not forget that with this remote cluster support, NMaaS doesn't lose the option to deploy applications on the cluster where itself is running. And basically, this can also be seen as an added feature where finally NMaaS can bring both local and external network visibility at the same time. Local visibility by deploying the applications on a cluster running on-premise, and remote visibility for the infrastructure by deploying monitoring applications in the NMaaS cluster running in the cloud. The plan is to pilot this new use case for deployment of a bundle of network monitoring applications across a distributed environment. And this will be piloted by Renater. Their use case is that they would like to deploy network monitoring and network management applications across various POPs that they have across France, various points of presence. And the architecture here is that each point of presence is represented by a single node Kubernetes cluster, which can then be onboarded to a central NMaaS instance. And these single node Kubernetes clusters will be managed by this central NMaaS instance, and will be able to leverage the centralized catalog of NMaaS, along with the full lifecycle management that is already being offered by NMaaS. We also have quite a lot of plans for the future, both concerning this new use case, the remote cluster support, but also to expand into new areas. So we are actively working on a new way in which NMaaS can be applied. So this is not necessarily a new use case, but it's simply an area where NMaaS can be beneficial along with the existing feature that it has. And this is the area of KPI monitoring. So NMaaS, along with already existing applications onboarded to the catalog, can be used to track key performance indicators for various teams. By key performance indicators, we mean metrics that can be obtained from external sources. In the case for the NMaaS team, this means, for example, tracking the performance on GitLab, the number of open issues, the number of closed issues, the number of releases within a given time frame, but also acquiring data from NMaaS itself. So the growth of the users across time, the growth of applications, the number of new application versions, and so on. The way that this works is basically using a combination of multiple applications already onboarded to NMaaS. And these applications are first and foremost NA10 as a workflow orchestration tool that can fetch the data from external sources. NA10 then persists the data to a database, which is also available for deployment on NMaaS, for example, PostgreSQL. PostgreSQL can be managed, so databases can be created, schemas can be created, tables can be created using a web interface application such as Miner. And finally, the cherry on top is Metabase, which is basically a business analytics application which can connect to a given data source or PostgreSQL and can visualize the metrics. That it can create nice graphs for comparison. So it can aggregate information. It can also provide historical comparison over time. Also for the remote clusters functionality, basically this can also be seen as an enabler for so much more. So not only aimed at network management applications, but aimed at general purpose applications with a strong strong ability to also influence deployment of AI-based applications. So one idea is basically to use NMaaS as an enabler for AI workloads. In practice, this would work by allowing NMaaS to pool distributed resources which are scarce. So for example, remote compute clusters which have GPUs on them. With a centralized NMaaS instance, NMaaS can schedule AI-enabled applications on these remote clusters. And furthermore, with the already implemented feature for time sharing, where a given application that is unused can be paused and then resumed. This feature has already landed in 1.8.0. This can also play as an enabler for such AI-based usage of NMaaS, where a given AI application acquires an access to a GPU. When it's not used, it's simply scaled down, it's paused, and the GPU can be released and can be allocated to another different application. So we see that the support for remote cluster management has a lot of potential, which expands beyond network monitoring and network management. We are always active on social media. We also have a blog on docs.nmaas.eu where we post news and also application tutorials. And we also have a LinkedIn group where we disseminate information about NMaaS, about presentations, and any activity related to the NMaaS team. So if there are any questions, we would be happy to answer them both with Lukasz in the Q&A session. Thank you very much.